Okay, so Chris, I think we're gonna start. All right, so hi everyone, and thank you for joining our webinar today. My name is Zev, and with me we have Chris Bicong, a senior engineer, joining me today. In this webinar, we'll outline the critical challenges and market trends in the service provider industry, and we'll add more detailed impact or more colors via real-life case study examples. Feel free to place your questions at any time in our Zoom chat, so we will answer the questions at the end of this webinar. Before we start, I will just assume most of you are familiar with Niagara Networks, but I will do like a 60-second brief. Again, company was founded in 2017. We're self-funded and owned by Interface Master Technologies, our parent company that is active over 20 years. We are based out of Silicon Valley and design and develop locally our entire range of network visibility solutions. We have over 300 customers that span multinational service providers, large enterprises, and government agencies. We have also over 25 cybersecurity and networking vendors under our Technology Alliance program. So practically those solutions integrated in the mission and critical projects. Some of them you will see during this presentation. Our solutions products typically deployed in core networks as a sort of a mediation layer between networks and cybersecurity tools. Typically assistance for security network operation with packet data visibility and network intelligence. Definitely for more information, you're more than welcome to visit our website. And with that, I think we can start. So that's a nutshell about Niagara. Right. Okay, so I would like to start from a macro view of the service providers' challenges. So over the last several years, the exponential growth in digital content and services increased choices, innovation, and competition in the marketplace. So when obviously the massive disruptions push network operators into transformational projects to sort of reinvent their business model and monetize their main assets, basically the network. So the network was and will remain the fundamental asset, but network operators deal with the complexity of traditional or sort of hybrid traditional and new infrastructure, complex operational processes in the design, operation, and maintenance, plus the cultural change, and take on top of that the regulations that slow down the required transformation towards the digital service convergence. And in our industry, typically what's known as a network as a service terminology. Another critical factor is the horizontal expansion of cloud services that placed the industry at a crossroads. The pressure of transforming the network to an on-demand consumption model with full automation and abstractions of the underlying infrastructure is a classic cloudification model. But it's a complex change of the telecom DNA, and for those of you that are practically coming from this space, you definitely know what I'm talking about. But to clarify this point, the radical change in consumption from fixed to pay-as-you-go models is really total DNA change. And that is really taking place to create a new method of self-service provisioning, elasticity of the network. This means in a macro view that the network services can easily scale up or down to support changing communication service needs of a customer and serve any type of application. But if we'll compound all these challenges and really highlight on top of them the security challenge, we are adding another major complexity of a really wide spectrum of network security aspects. Specifically for the mission critical infrastructure like in telecom space that should be always resilient, backed by service level agreements and serve as a wide range of customers, services, and applications. So transforming to a new norm of network and service and being a digital service provider requires security and network operation teams to measure and secure the entire connectivity domain, which practically spans from the initial demarcation point of access across the wide area network infrastructure up to the global and the regional peering points, so to the outside domains. Typically, it goes towards the public, private cloud, and many dynamic virtual demarcation points. For large operators, the complexity spans national, international boundaries, so the scale of the problem gets bigger. And network operation centers and security operation centers are under significant pressure to operate and guard the connectivity domain and the wide range of digital services. So this fact, if we have a glance on the aspects, the visibility into the entire spectrum of the 360 degrees of assets, regardless if it's fixed, mobile, virtual, or physical infrastructure, and capture the required data to knock and soak is becoming a complex task. In addition to that, the growing volume, velocity, and complexity in network traffic flood the service provider monitoring and security tools with more traffic than they really designed to handle or defined in terms of initial definition. And oversubscription methods that have traditionally been used require better planning. So take on top of it this epic evolution of virtualization and the cloud, and which practically added another operational challenge that faded the boundaries, traditional boundaries in security models. Thus, if we look at the challenging aspects, the CSO and CIOs, how they lead their NetSec and lately DevOps collaboration playbooks is a major issue. The fact that digital transformation intensified during last year is definitely not a cliche. Customers increased their dependency on network operator services, and they expect the maximum network and security resiliency. And therefore, if we look at the substantial aspect of the network, any network degradation, outages, and security breaches can impact the connected enterprises, peering partners, and sometimes millions of customers. To emphasize maybe the previous slide in a more bolded way, we can see the evidence that security breaches in telecom space intensified during this year. And as I mentioned previously, the communication services span a very wide attack surface. This attack surface can impact many types of customers and mission critical services. They become a relevant target for criminal actors and state-sponsored threat actors. Basically, those guys can create outages or breach telecommunications service provider networks. And the fact is that they can move laterally until they have unauthorized access to infrastructure, which practically enables them to record voice calls, collect copies of essential data, or gather packet data of customer network traffic. So the breaches, telecommunication companies can have a significant impact on their retail, enterprise, and government customers, and anyone that really connected to this mission critical infrastructure. Take several examples on this slide. You can see that the latest research by Intelligent Insights exposed the fact that selling telecom breaches on hacking forums represented 22% and was the most affected industry. So the other latest security breaches that were publicly announced were the T-Mobile breach that you probably heard about, and They admitted unauthorized access to over 100 million users' data. Telia Carrier, which is a very large multinational Nordics service provider that released their new research actually this year on a new massive peak of denial of service attacks, carpet bombing attacks, and the last one, at least on this specific example, is really the Orange outage. Orange is also a global telecom provider, so the Orange outage investigation is still in progress. Okay, I would like to move to the four major use cases that we typically address with our solutions and follow after that with case studies. So, Chris, you're here, correct?
Yes, I'm here.
Okay, good. So I'm moving to the next slide. So go ahead.
Zeb. So for a lot of these service providers, large to small, so we just basically categorize four major use cases that have been deployed with our network visibility solution. The very first one here, the Infrastructure Security and Monitoring, it's the most common used one. Essentially, they needed a visibility solution that can tap, aggregate, filter, and even do some decryption of that production traffic, and then send that relevant traffic to the specific tools where the tools enforce security policies, for example, or they need to do network performance optimization, or even forensics for implementing or enforcing security policies. And the next one here in the inline tools protection, essentially we provide a solution that can increase connectivity resiliency for always on inline security service chaining and load balancing with the bypass capability. So in addition to that, it also allows for granular scaling of the appliances that are inline in order to provide those additional services, and all while mitigating that single point of failure for such inline devices. So this is very important to a lot of service providers who need to protect their investment in their existing tools, for example. The third example here, the use case, is the Security Operations Center packet data delivery, and also for compliance. They require a visibility solution that can extract application or traffic flows metadata, increase efficiency by removing the duplicate traffic, or removing private or sensitive user information prior to archiving in data lakes. And then the fourth one here is for cyber testing. They needed something that can complement their penetration testing in some cases where their application can be virtually hosted right on the visibility platform. Next slide. So we're going to be going into the real life use cases. We have several across several markets around the globe, actually, from large service providers to mobile network operators to triple play service providers. So we run the gamut in terms of the different actual deployments around the world. So it's not very specific to just a large service provider, for example. We can cover many services. It's a pretty wide support of this network visibility solution, where it becomes very critical for them to implement to complement a lot of their security monitoring optimization type tools. Next slide. So this first use case is a very large service provider in Canada. They have one of the largest footprint in terms of deployment in North America. I believe they're one of the top 3 service providers in Canada. So this is very unique in a case because they required automation. A recent migration of all their point of presence, all their POPs, from lots of 10 gig links to just multiple 100 gigs moving forward, because most of that demand was realized last year during COVID, as everyone knows, where the infrastructure was pushed past its limits by the subscribers. What is working from home, that obviously much increase in terms of the bandwidth demand. I mean, they also needed to protect their existing tools that were only 10 gigs. So they basically needed to spread that traffic around. So they require a solution that can be seamlessly integrated into their new architecture, where automation was extremely critical. because their resources basically was not going to be able to keep up with the new changes that was happening. So they chose a visibility solution with full API support. So as you can see here in the diagram, for example, you have the NOC, the Network Operations Center, being able to enable or disable existing or even create new services periodically that would turn in populate. They have a database with specific information being recorded or recorded on this database, depending on the application that's being enabled or created. Some of that information, for example, could be certain IP subnets, certain TCP ports for specific applications, or even using certain VLANs, for example. They have a proprietary application with automated scripting that pulls and extracts information from this database that will detect any type of changes. So with specific traffic that needed to be, for example, secured or need to be monitored or optimized, this is constantly being pulled by this proprietary application. And the communication to that visibility platform is using the REST API as well as SNMP, which can configure traffic flows and filters with specific criteria extracted from that database, and then basically forward specific traffic to those tools. So this is fully automated. There's no human interaction that's involved. Essentially, this application runs 24/7, polling that database. And then this results in significant operational OpEx savings, because essentially enables the ability to monitor secure services, basically no human intervention, and increasing the overall efficiency through this automation. But this is very unique. They're one of the first ones to do this fully automated implementation of the network visibility solution. Next slide. Next slide, Zed. Oh, sorry. There you go. So in this case, this is a carrier grade web filtering in a service provider network. The challenge here was that the customer needed to provide internet access to a very, very large education network, especially it's almost countrywide. But they also wanted to enhance the value of their offering with very safe internet service, obviously for educational purposes. A lot of kids needed to get on the internet for doing research and such, and doing their assignments. So they needed an efficient web filtering solution that did not slow down their network or become a risk to their network. Obviously, they wanted to protect their infrastructure as well. And as with any large service provider, they also wanted a scalable solution with high availability, so that they can provide such solution to basically comply to their SLAs to these schools. The solution was with NetSweeper, where they deployed the Niagara Networks TAP in order to get 100% copy of the traffic from multiple 10 gig links in the network, and then basically aggregate that into our packet brokers. The packet brokers aggregating those 10 gig links, and then also being able to filter out irrelevant traffic. So only the HTTP gets and TLS client hello traffic were forwarded to multiple NetSweeper policy servers in a load balance configuration. So this allows for scaling as traffic demand increases. They're able to scale this very, very easily because they already have the taps in place where they can get 100% of the traffic, and we have an aggregator, and it's just a matter of adding those policy servers as traffic demands. So this basically, the NetSweeper only receives the URL request and able to process and filter the web traffic at a very high capacity, something in the neighborhood of about 300,000 web requests per second per server. So you can see how big of a scale we're talking about here in terms of how much traffic is being filtered. So it's very very seamless in terms of the integration and scalability of the solution. So the result was that the customer can offer a safer internet service where the internet access is filtered from the web threats such as virus, malware, phishing, and negative content inappropriate for students using highly efficient solution, and also providing them with the lower total cost of ownership of the entire solution. The solution itself works mostly in out of band mode in terms of the visibility, but the NetSweeper is able to enforce the filtering, for example, because this is an inline that's communicating to their outbound routers. Next slide. So in this specific example, this is more of a core on the backbone implementation. This is another large service provider in North America where all their links are 100 gigs. And even on the network facing side, they have these ASR 9Ks, the Ciscos. That's all 100 gig links, and they're actually aggregated across 4 of them per data center. So this is each data center. This is the connectivity for each one. It has a diverse connectivity to their backbone. With the since the current traffic activity is less than half of full capacity, this specific deployment currently is being they opted to do a one-to-one failover. So they have a side A, side B in terms of the connectivity. So it's an active standby type of implementation, but they're able to scale this at full capacity, essentially load balance across both connections as needed as the traffic demand increases, obviously. So, and this is an example of the always-on inline security, basically mitigates any single point of failure while enabling scalability. There's a lot of filters that's being implemented, but this is all line rate, so it doesn't affect the performance of the network. It enables them to have granular or selective service policy enforcement without adverse impact on the network performance, as I've mentioned. Basically, they're only selecting certain types of traffic. So what they're categorizing as trusted traffic can only pass through firewalls. So that can be distinguished by the headers of the traffic. So for example, certain IP subnets, TCP ports, certain applications are running, for example. We can even implement filters using regex or regular expressions to look at deeper into the packet. So they're also looking at the entire header, even some of the payload in order to implement those filters. So the trusted traffic is only going to firewall. The untrusted traffic, meaning it could be, a lot of that is external traffic required to pass through both the firewall and the intrusion prevention system, or the IPS. So in the case of where the IPS fails, they still wanted all traffic to pass through the firewall in this specific example. So we mitigated that point of failure across the IPS. And if both the firewall and the IPS failed in this scenario, all traffic will migrate to the diverse side, so that it also has the same type of failover on the diverse path. So there's quite a bit of operational expense savings in this case, because the amount of resiliency that was built into it, not just on the physical and even on the logical layer. So this decreases their mean time to repair at any time. And then in terms of CapEx, we combine the functionality of the bypass and the packet broker so that they can implement various filtering capabilities so that they can basically direct where specific traffic needs to go in their inline security devices. So this is a combination of both. Instead of having a stack solution, it's combined in a single one while offering that protection. So this is a significant CapEx savings for them, and the reason they went with the Niagara solution. Slide. So for this specific example, this is one where a use case where the network side needed to scale up to 100 gig from multiple 10 gigs, but their existing tools, because 100 gig interfaces are quite expensive, as many of you know, in terms of some of these network tools, they wanted to do the granular scaling, since traffic growth typically can scale exponentially and not linear. So it couldn't keep up, and investing in the tools at 100 gig didn't quite make sense for this specific customer. So we were able to mitigate that by providing our visibility solution plus the added protection of the bypass. The DDoS solution, they wanted to only scale at 10 gig at a time. So they needed that traffic, that production traffic utilization to be equally distributed while maintaining all sessions. So this is very unique, because some packet broker solutions out there in the industry, they do not maintain the sessions, traffic sessions. So that's critical in a lot of these security applications, because they need they need to be able to see the symmetrical traffic. So if that's broken, it will never hit their policies. I know this for a fact for Fortinet, so it's very, very important. So that's a very critical feature that was required by this specific customer. And then also the ability to scale multiple inline devices to be able to distribute that traffic, gave them quite a bit of savings, and that it didn't force them to upgrade to the 100 gig for these inline appliances, and for the fact that we are able to load balance that traffic, even though their network side is going to 100 gigs, and they can even grow to multiple 100 gigs and continue to keep the 10 gig. So this is a significant savings for this specific service provider. For this one is a mobile network operator. Essentially, they wanted to improve their quality of experience for all their subscribers. So they had EPC tools basically doing analytics and providing any optimization recommendations on their mobile network. But they needed a network visibility solution that can correlate the traffic, the control traffic with the user data, and be able to send that to multiple tools. That's quite a bit of CPU power that's required to do that, especially when it's relegated to the tools. So they wanted to remove that work, basically an offload of that work from such tools, and they need a visibility solution to do that. So with the Niagara solution, we're able to correlate the traffic flow based on the subscribers and allow to seamlessly scale and integrate any EPC tools for advanced analytics and insight, resulting in improved subscriber quality of experience. And as we know, if the quality of experience is improved or it's at a high quality, then you either maintain and gain new customers. Is the opposite. If you don't have that quality of experience by users, obviously they're going to go to some other provider that has better experience in the services that they provide. So they're able to do that and efficiently, effectively monitor the performance of their subscribers without any type of disruption, because all of that traffic is being correlated. The N2 series that was implemented also has the capability of the what we call open visibility platform, that's able to virtually host any kind of mobile monitoring and security application software, making it essentially a future-proof solution for this specific mobile operator. So they can do sandbox of the tools. Maybe they're doing evaluation of specific tools. So instead of deploying these third-party applications or that can provide analytics and maybe the cloud or bare metal servers, they can now implement this on their network visibility platform. Just a matter of adding just one module that can host any application virtually on their visibility platform. In this case is another mobile network operator. Essentially, this is just the basic tap and aggregation of all traffic. And they needed it to be able to generate reporting of the services and all the subscribers usage, and basically, that'll dictate the billing. This is they also wanted for extension, if they needed to do any kind of GTP correlation in the future, they can essentially easily add that to this specific implementation. But at the day one requirement is just basically gathering all that information and be able to tap across multiple links and aggregate that. And so this allowed them to do that without any significant change to their infrastructure, because before they needed to do, for example, spans of some of these switches or routers, and it made it quite difficult creating access lists. And so they wanted to remove that human factor in terms of any significant changes in production infrastructure by essentially implementing the tap and aggregating all that traffic. And this made it very simple and seamless for them to implement in order to create those reports and billing per subscriber, and also giving them the added benefit of expanding to do the correlation in the future. And next slide. This one is similar to the previous example. This is a large telco in EMEA where they needed to get access to the production traffic using the Sandvine. This is the IQ42 300. If they're not familiar with this, it's an active logic that enables full suite of network intelligence and policy enforcement capabilities. Basically, it does a lot of the traffic identification, classification, the congestion management, traffic application prioritization. So this Sandvine device does a lot of analytics to provide optimization of the network, but it needs to sit in line of the production traffic. And so inherently it becomes a point of failure in the network. So it's not just a bump in the wire anymore. It actually, if that fails, all that traffic stops. So they needed a solution that could easily integrate and seamlessly be added into their the deployment. And the Niagara passive bypass solution was used because it can also scale in terms of as more traffic increases. They can connect across multiple of these modules. You can easily add it to them. And so in this specific example, it's multiple 10 gigs that's added. So what it does is basically provide access to all that production network while mitigating a potential point of failure. So at any point, if that Sandvine box fails, it'll trigger the bypass in a matter of sub 50 milliseconds. So it doesn't trigger a network reconvergence and protect the connectivity and resiliency of the network.
Okay, Chris, thanks. I think the case studies definitely were relevant to emphasize the aspects that we discussed previously on the market. Before we move to the Q&A, I would like to really recap this webinar and emphasize our value proposition as a company, at least in this space. Telecom industry is still going through this massive structural changes, and I truly believe that the case studies section that Chris was covering here was just a snapshot of our activity and the maximum value we can expose here. I certainly would like to emphasize that service provider sector is one of our strategic markets with really big and substantial customers in national, international footprint level. Niagara, in terms of DNA as a company, we definitely agile for this very demanding telco space and their requirements. And we established field proven and fully open and also interoperable solution with really large industry leading vendors. I think you noticed in each case study the names. Typically those big leading vendors, they construct the security stack and network monitoring stack. And we as Niagara, as a single source of this wide range of visibility solutions, we continue to help these customers in their transformation journey. Specifically as the number of various heterogeneous tools required by security and network operations will continue to be high. And integration of our solution help really to increase the network uptime and improve the efficiency of the required packet data collection and the intelligent delivery of the relevant traffic to security operations to improve really the network security posture, regardless of its on-prem or hybrid cloud environments. We didn't really cover the hybrid cloud environment in case studies, but I believe that if we look at the super cycle of network as a service transformation, it's still in early stages, and our latest projects in this market reflect just the indicative trend. So we hope to bring more field insights in our next webinars. All right, so we hope you really enjoyed this webinar and appreciate your time. Maybe let's move to questions. We have a couple of questions. Let me see. So one question is if my current infrastructure has the capability to provide traffic statistics, why do I still need to deploy network visibility solutions? So Chris, you want to take it?
Yeah, sure. So if those statistics from the devices you have currently in your infrastructure meets some or all your requirements, then probably you may not need a complete visibility of your production traffic. But if you don't have a complete visibility of 100% of your production traffic, or you need to seamlessly integrate new tools from various vendors for monitoring, forensic, security optimization, now or maybe in the near future, or you need to scale network capacity while protecting those current tools and avoiding costly forklifts, as you saw some of the use cases, or even increase resiliency and mitigating a single point of failure for some of your inline devices, then the answer would be yes. You do if you do need that network visibility solution. Is very, very critical if you answered yes to any of the above. So that's why a lot of these service providers are implementing a network visibility solution, specifically in the Niagara.
Okay, another question came in. How does your solution allow network scaling while maintaining existing appliances at lower speeds? So I think it's relevant to one of the slides that was discussing load balancing. So you want to take it or?
Yeah, go ahead.
Sure.
Go ahead.
No. Go ahead, no problem.
Yeah, like you said, this is a pretty common use case because large service providers and even large, some of the enterprises where traffic demand increases, which dictate the network scale on the network port. So for example, they're going from 10 gigs, multiple 10 gigs to 100 gigs, and that's usually, it's a very abrupt spike in terms of the traffic demand, so the capacity needs to keep up, but the tools that they have in place, as I mentioned in the past, may not have that same capacity, so they have to do a granular scaling of that, and also they need to increase efficiency because they may not need to shove all that production traffic to the tools. So this is it becomes a very, very costly investment if they're trying to keep up with that. So they needed other ways to mitigate that type of cost, even potential forklift. So with the network visibility solution, you can mitigate that by improving efficiency in terms of what traffic gets forwarded to those tools, and also allows for granular scaling in lower increments. So maybe not all that 100 gig traffic needs to go to your tools, maybe only 30, 40. So you just need to add maybe a couple more 10 gig interfaces on the tools, or tools that are at 10 gigs, and you can load balance that traffic for the actual traffic that's being sent across the network. So a protection in that sense, in terms of your CapEx, long-term CapEx, and also your investment in your existing tools.
Actually, it's interesting. If just to add additional color on this one, you mentioned CapEx, and for people on this call that familiar with the prices of 100 gig next generation firewalls, if you take the 100 gig platform, it can go north of $500,000. So if you have easily, exactly. So if you multiply the number of 10 gigs that you can really sustain them and still even increase them to 40 gig without jumping to the end game to 100 gig is a huge CapEx saving, and it's also a gradual kind of step for the telecom operational team. So that's important for this type of deployment. What do we have? Last question, or I think it's last one. Do you see more of point of presence or central offices transformed to application centers or sort of core architectures, and how this imply on network visibility and security? Okay, so looks like this one is really for a knowledgeable person on the industry. practically the cord, yeah, it was mentioned as a cord. Cord is a central office re-architected as a data center. So it means that, you know, the telecom huge central offices and even very large point of presence, they starting to be really look like big data centers or application centers, which means, you know, it really imitates this horizontal shift of the cloud environment, meaning a lot of east-west traffic, a lot of dependency on in-entry exit points, a lot of application servers. And that's something that definitely just creating more and more demand for packet data visibility. You know, packet data is really the single source of truth for security people and their tools, and absolutely for network operations that typically need to deploy and plan the capacity of the network. So that's definitely an interesting question. There is another question here. Do you have any 5G deployment use case example where you had significant control adding value to the solution? Okay, so Chris, I can take it and you can put additional color. Yeah, okay.
Sure, go for it.
So 5G deployments today, and I have to admit, most of them are NSA, which means non-standalone. So it's a hybrid of 4G with it's kind of extension of EPC switch between the 4G and 5G. And those are the I think this is the use case that practically we face in the field, which is there are not a lot of standalone 5Gs yet, but it's coming. So regarding the question on 5G deployment, we have 4G with a switch of non-standalone 5G. Currently, it's again just basic level of load balancing and protection, in addition to the GTP correlation, which is acting as part of the 4G infrastructure. So I hope that if I answered the question here. By the way, somebody also asked if the webinar recording slides will be available for pre-sales and other colleagues. Yeah, so first of all, the recording of this webinar will be published. So anyone that couldn't attend, yes, we're gonna send notification with the relevant link, and people definitely can use it as additional vehicle to distribute the data to their peers. I don't see any other questions, so I believe that we can really wrap up this webinar. Chris, thank you very much for your section, and I hope that again everyone really enjoyed this webinar. Absolutely good to see some level of interaction here, and thank you very much. We're finishing it now.